Something that came up to us yesterday, I was coming up looking at it, and it's my first time looking at this machine in a while. And nobody's made any adjustments since the factory startup. And as I was looking, I do my typical walk around on the PMs, right? So I'm here at the condenser screen, and I'll take you into that a little bit more. I am logged in on a service access, so I can see everything. So I do my normal inspection checks. I'm walking around, walking around. This is typically what I do. I come over here to my liquid level sight glass and I shine in there, and my liquid level was right here to the bottom of the glass. So when you can see the top of the subcooler in there, that's that big shiny plate in the bottom. So the top of the subcooler was actually above the liquid level. Well, that's a really big issue. The liquid level in the condenser is really critical to make sure the whole machine is functioning properly, because that plays into how it's going to balance the entire refrigerant load. And it decides how to move the metering valve based off of what the liquid level is in the condenser. So when the condenser itself has too low of a liquid level, then it's going to push too much refrigerant into the evaporator. That can cause low superheat and flooding issues. That's a whole separate problem. But the bigger issue that they tell you about when you go to the factory training for this is if you allow that liquid level to get too low, you'll rub a hole in the subcooler section of the piping. So on this machine, you've got about from, say, up here towards the top down to about halfway or so is your desuperheating tubes. This is where the bulk of the heat gets rejected. And by the time it comes off of those tubes, we are down at saturation temperatures falling into the bottom as a liquid refrigerant where we go through the subcooler. So the subcooler portion is from the bottom and comes up about, say, right here, which you can see here at the sight glass. These sight glasses are not machine perfect by the factory, and that's part of what they tell you. And I'll explain how you're supposed to check this in a minute. But because these aren't machined, these are not perfect units of measure. So just going based off of sight glass level is not sufficient, because it is going to change and vary depending on each machine you're working on. So the subcooler bundle is housed inside of a stainless steel shroud, and it runs the whole length of the barrel all the way down from one end to the other. So inside of that housing, the tubes are just in racks, and so there's a metal rack in there where the subcooler tubes run through. The refrigerant comes down and underneath and kind of swirls up into that rack assembly, cools, and in the middle of the condenser is where we have our liquid drain, which goes to our metering valve on top of the evaporator, which is sitting right over here. What they warn you about is if that liquid level drops too low, it's going to cause turbulence on those tubes, and those tubes are going to have the ability to rub on that rack because they're not secured in any specific way. They just rest in there. So it is imperative that we don't have too much turbulence, which is going to allow a lot of movement on that tubing, which will lead to eventually rubbing a hole through it. Now, this isn't something that's going to happen overnight. This would be something that would progressively happen over a period of time and get worse and worse and worse until eventually it just leads to an all-out failure. So what they tell you at the factory is you want to be looking through this sight glass dead on, and your refrigerant level should be 3/4 of an inch at minimum above that plate as solid liquid. Typically, we aim for 3/4 to 1 inch above that, so that we can make sure that we're maintaining a high enough level that turbulence is not allowed to impact the tubes in the subcooler. So then the question becomes, well, if there was factory startup, it's a very new machine, why did the factory leave it like that? Or did the factory do that? Or what? Just how does that even make sense? Because if I know this and I've been through that training, why didn't the factory technician do the same? Ultimately, it may not have been the factory technician at all. Somebody else could have adjusted that at some point, not knowing any better. But looking at it, I think I figured out why they made that adjustment, and it tied back into water flow. So there was a water flow condition, and I'll show you exactly some of the parameters, what it looked like. Not a literal live example, but I'll recant what happened so you kind of have a picture of how I fixed the issue, but then found the real problem that was what I think caused them to make that decision. So part of what happens is when you raise that liquid level, you're increasing how much heat the condenser does hold because you're running a higher level in the condenser. The same way it would do with a regular split system condenser. The higher the liquid level, the little bit higher head pressure you're going to run. So in this particular case, we were having a flow problem because the chiller behind me is decommissioned, is fully mothballed. but the ISO valve in the condenser water is not functioning, and it was allowing flow to run even though this chiller was on as well. This chiller needs a dedicated pump to run with it just to maintain proper flow on the GPM. So because both of these were allowed to flow together, it was throwing off the condenser water flow and was causing our head pressure to run elevated. Now, one of the ways you can correct for this is if by lowering the liquid level in the condenser, it would have given you the ability to reduce that head pressure, stay away from the surge line, which could have been one of the things they were struggling with initially, is if the surge line was riding a little too close on that, they may have been trying to stop it from going into a surge, which the fix for that would have been the water. But by lowering that liquid level, we did reduce enough pressure on the condenser to allow it to stop trying to surge or have any other kind of high head pressure conditions. But again, the flow was the problem. And this plant had the ability to have the flow corrected. So here from the home screen, we're gonna go to the condenser, and then we're gonna go to level control. Now you need to be in service login for this to work. This was originally at 35%. We were maintaining right at our 35% with absolutely no issue. And we were also pushing a 10-degree subcooling temperature. And so, which is a lot. You know, 10 degrees on this machine for me is a lot. I normally don't see them run quite that high without a really high load, which this machine didn't have at the time. But one of the other things I was noticing was we were pushing in about 79-degree water, but we were pushing out right at 90 degrees of condenser water. So we had like a 12-degree split across our condenser. In addition to that, our saturation temperature was up about 95, which was excessively high for this machine. It does not typically run that much. By me coming into the level control, and how I did it is I bumped this up with it running. I did it with it running, but I bumped this up 2% at a time until I got to 42. So by the time I hit 40% from 35, I was at about half an inch above the subcooler plate, and then another 2% got me right at that 3/4 of an inch to 1 inch mark. It was spot on perfect. The machine was holding it. And so what you do is, as you slowly adjust this, you let the condenser liquid level balance itself back out, and when it stabilizes again, because we've got to start controlling that, you know, how it's doing that is backing down on this valve, which is backing up more refrigerant into the condenser, and then that level, that percentage in the condenser is telling this valve whether to open or close. So as it was doing that, we eventually got to where we were able to head off at our 42% constant level. And that's where I saw that we had our just really high conditions here on the condenser, and it was a little lower. So when I first walked up to it, we were sitting about 87, so we were pushing that 10, 11 degrees split across the condenser, but we were still running about a 92, 91 to 92 on the condenser saturation. So by me adjusting that liquid level, I increased that by a couple of degrees on both sides, the saturation and the leaving water temperature, which that's what made me begin to realize I possibly had a flow issue. So I brought in a second pump just to see what it would do on the header, because all these chillers are tied in on a central header. They're not a primary pump. And that immediately dropped me back down. I had about an 8-degree split. I came down into about 88 with about a 78, 79 coming into the machine. My subcooling came down to about 7. My saturation temperature came down and was floating right about that 89-degree mark, which I was very happy with. And that ultimately was the final resolve.
I appreciate Phil Pulse for sponsoring this video and just being a continued partner for the HVAC Time brand and just everything we're trying to do here. With that, they make incredible sales tools to really help your team work together, coordinate and collaborate between your salesmen and your field guys. They've even got excellent pricing book options built into it, to where if you do any kind of flat rate, or if you've got any form of pre-built pricing that you want to use in the field with your team and help coordinate between your in-house team and your field team, they've got the tools, they've got the resources, they've got some incredible systems built out that really streamline the whole process and then integrates all the billing and the accounting into that same system. So is a wonderful tool. There's a lot of great benefits to using something like PhilPulse. They're an amazing team with tremendous customer support. I could highly recommend them. I really think you ought to check them out, talk to them. You'd be surprised on how much they can do for you and just how far they'll go. I've been working with them for a little while now, and I got to say that I really enjoy the amount of attention and effort they put in to just making this trade better and providing a really good service.
Once we got it stable, I was able to isolate this chiller off to where it wasn't going to flow through here any further, and that was going to remove that from the equation. These two do not have ISO control, so that is something that is pretty important if you're going to try to stage your pumps. And I am going to recommend to the customer that they try to get the isolation system functioning on the condenser water side. It does work on the chill water. But hindsight through this whole situation, I genuinely believe that they were dealing with some high head pressure issues or high condenser water temperatures. They were just dealing with issues on the condenser water side. They try to resolve that by lowering that liquid level, which is a very dangerous thing for this machine. So just something you need to be pay attention to, be very careful of, and don't fall into that same trap. Don't let the water flow issues trip you up and make you think that we've got some kind of refrigerant problem that you're trying to address. There's nothing special at this machine. It was very specifically designed to run at the liquid level where it's at, but that also means that the water and everything else has to run along with it. I hope you enjoyed this. I hope it helps you in some way. This is just something we caught preventative maintenance, just coming in, doing a general inspection. These are the kinds of things that I'm looking for and I'm watching for, and when I walk into a plant, I'm doing a walk around, and especially with the YK, I'm checking those sight glasses, I'm seeing what they're telling me, and I'm allowing that to help me determine whether or not I need to do something, because before I take any logs on the machine, I want to make sure that everything that I want to be in place is. If there's something that stands out to me that I don't like, I want to know about it and document that first before I start logging readings. Because when I start to log readings, I want to take a full snapshot very quickly and just go through and take all my logs through my documentation for our inspections. These machines do have a print function through like putty and such. It's just not something we do on a typical inspection. You know, we have our own independent forms that we're going to fill out. We're going to make sure those are as accurate as possible, which also means that we need to grab the data as quickly as possible so we get a clean snapshot of that actual moment inside of that chiller. Y'all have a good one, MTT.